Assalamualaikum and hi, I'm Balkis. In this presentation, there are 5 subtopics will be presented, which are the introductions, objectives, procedures, results and discussion, and the last but not least is the conclusion. Menstrual is an organic component. It is either can be origin of coal or oil shale. These terms of menstrual is referred to coal, but sometimes it is similar to the terms minerals that referring to the igneous or metamorphic rocks. The examples of the major groups of menstrual are liptinite, vertinite, and inertinite. The menstrual analysis is a micropetrographic determination method. The investigation of peat as well as brown coal and lignite is carried out according to the microscopic visual characterized components. It will give the details on composition of organic matter based on the volume percentage of a mineral matter. It is because menstrual are the components of the source rock which describe the origins organic matter in coal and also organic rich shale. It is because menstrual are the components of the source rock which are describe the origin organic matter in coals and also in organic shale. Based on the journal that we have referred, it is about an investigation on tertiary coal from Muka and Balingan, Sarawak. The aim of this investigation is to evaluate the regional rank variations, hydrocarbon generative potentials, and reconstruct the paleo-environment condition during the peat accumulation. However, there is a standard or characteristic for a good source rock potential for tertiary coals, which are high total organic carbon contents or TOC and yield of bitumen extraction range from 31.3 to 55.9%. Balingan are located at the area that dominated with type 3 terrigenous kerogen, while Muka are dominated by type 2 and 3 kerogens. So menstrual analysis have been used in this study to know the details of the tertiary coals. Now, I will invite Ahmad Farid to talk about the objectives of visual kerogen or menstrual analysis.
Thank you, Balkis, for your introduction on this topic earlier. Hi and Assalamualaikum. My name is Ahmad Farid bin Ahmad Murshid, and now I will presenting about the objective, the results, and the discussion for visual menstrual and kerogen analysis. Moving on to the next slide. For the objective on menstrual and kerogen visual analysis, there are 2 objectives. The first one is to obtain the information about the type and maturity of organic material present in rock samples. The second one is to obtain information about hydrocarbon generation potential from general visual inspection of menstruals.
There are 3 steps to do this analysis. Firstly, 45 samples are picked up from 15 sampling sites, 11 from Muka and another 4 from Balingan. Next, the sample will crush to a maximum particle size of 1 mm, and this is followed by the embedding the material in cold curing epoxy resin and the production of polished sections. Lastly, the sample will be transferred and performed on a Leica DM6000M microscope in monochromatic and UV light illumination on 1000 points. So here, we have provided to you the video on how to use the Leica DM60M microscope and how it looks like.
From the next slide, we will review and explain the result for visual, measural, and kerogen analysis from the journal that has been given from our lecturer. From the visual, measural, and kerogen analysis experiment, we can obtain a table just like this one, which is known as random vitrinite reflectance and measural composition table. From this table, we can observe many information. For example, on the left side of the table is the sample number for each rock that we have studied on. Next is the vitrinite reflectance percentage and the measural composition, which is huminite measurals, liptinite measurals, inertinite measurals, and its subclasses. For example, ulminite in the U letter and detrohuminite in the TH letter composition, measural composition for each of the rock sample that we are working on. Okay, the vitrinite reflectance percentage, for example, 0.35% for sample number E55/4 and 0.33% for sample number E55.3. For the next one is the measural composition, that is the information that we can obtain. For ulminite, the U letter is 23.2% on the sample number E55/4 and the detrohuminite percentage is 66.3% for sample number E55.4. It is the same to other main groups of measural composition such as liptinite and inertinite. Okay, with the data from the earlier table, we can summarize it into the table like this one. Okay, it shows us that the vitrinite reflectance value, the minimum and the maximum, and also the mean value of the vitrinite reflectance. Also, it can show us the most dominant measurals compared to other in all the rock samples. For example, the highlighted one is the most dominant measural compared to other types of measurals. As you can see, the ulminite is 92.7% in the rock sample and detrohuminite is 95.0% in several rock sample with mean value about 53.7%. The total huminite measurals percentage are 87.5% compared to other main measurals. For example, liptinite which is only 10% and inertinite which is only 2.5% percentage value. On the right side is known as ternary diagram, which indicate us the majority of the measural composition. As you can see, all the dots are accumulated in the huminite measural group and there are no dots on inertinite and liptinite measural group. This shows that huminite is the most dominant compared to other type of measurals. Next, we will discuss the result that I have explained earlier. With this discussion, we can achieve the objective of the experiment, which is the first one is to obtain the maturity of the coal that we have studied on, and the second one is to obtain the hydrocarbon potential for the source rock that we have studied. With the data from the table that I have explained earlier, which is the vitrinite reflectance percentage, which is the minimum is 0.26% and the maximum is 0.3%, and the average value is 0.32%. With this data, we can identify the coal rank and the maturity of the coal that we have studied on. So our mean vitrinite reflectance percentage is 0.32, and we can compare it with the scale on the right hand side of the slide. So the mean value is 0.32. So here is our value between 0.3 and 0.4, and the coal is thermally immature from the scale, and for identification, the coal is known as lignite. Okay, the coal is identified as lignite and the coal is thermally immature, and it is identified as lignite. Besides coal rank and thermal maturity, we can also indicate the source rock potential. Source rock potential can indicated by liptinite minerals. Liptinite minerals is minerals that have waxy properties. When high level of liptinite, the potential as the source rock from the coal that we have studied on is also high. From the data I have explained earlier, the resinite mineral value is 20.4%. The suberinite value also 39.6%. As overall, the total liptinite value, which have waxy minerals, is 40.8%, which is quite high in certain rock samples. This indicates that the source rock potential is very good to excellent. For the conclusion, we have 2 points. The first point is hydrocarbon potential. The coal field has a high potential as a source rock due to liptinite mineral value, but it has a low hydrocarbon content due to its thermally immature coal field. The second point is mineral composition. The coal from Balingan, Sarawak are mainly dominated by huminite minerals, with major amount of liptinite mineral in some layers of the rock and minor amount of inertinite minerals in the rock. That's it for this topic. We will move on to the next topic.
In literally, palynology is referred to the study of dust. In many years ago, the palynologists analyzed particulate samples that have been collected from sediment deposits, water, plant and the air. So from this analysis of those samples, the palynologists will get the clues on the environment, life and also energetic condition that produce the samples. The palynology also can be used to study fossil palynomorphs such as spores, pollen, orbicules, particulate organic matter, and also kerogens. Besides that, it can be applied to determine depositional environments, relative ages, reconstruct past vegetations, and also oil and gas explorations. So based on the journal that we have referred, it is about the early Miocene muka coals. So these coals actually were formed during the collision between Luconia block dangerous ground with the Borneo, that last from the late Eocene to the early Miocene. To evaluate the depositional environment of these early Miocene coals, the samples of coal with yield abundance of Casuarina pollens are collected, and that the palynology has been done on these samples.
Next, I will explain the objective by studying palynology. The objective by studying palynology are only one, which is to understand the environment and its energetic condition that produce the palynomorphs.
There are three steps needed to do this palynology analysis. Firstly, there are 8 samples that have collected, which are 4 samples of coals and 4 samples of non-coals, and then the sample will be dissolved in strong acid such as hydrochloric acid, nitric acid, and also hydrofluoric acid to separate the microscopic pollen and spores from their rock matrix. And lastly, it will be transferred the sample to microscopic slide and analyzed under transmitted microscope to do the analysis. This video will show you the steps to do the palynology analysis.
From the procedures and experiment that have been done, we can obtain such results, and from the result, we can indicate the paleo environment and depositional environment of the coal, of the rock sample that we have studied. From the experimentation and procedures that has been done on the journal that has been given to us, we can obtain this table which contain a bunch of informations on the palynomorph on the rock samples that we have studied. So there are several information. First is the palynomorphs. There are 3 dominant palynomorphs exist in our rock sample. The first one is Casuarina, the second one is Calamus paspalentus type, and the third one is Cephalomappa. And the rock sample are divided into 2 categories. The first is non-coal and the second one is coal. And the numbers here are the name of the rock samples, and the numbers beside the palynomorph indicates the value of the palynomorph in the rock sample. For example, 44 of Casuarina palynomorphs in 038-2 rock samples, and 36 Calamus paspalentus type palynomorphs on 038-2 rock sample, and 12 Cephalomappa palynomorphs on F2-2 rock samples. This table also can indicate the most dominated palynomorph amongst the other. As you can see, Casuarina palynomorph is the most dominant compared to other type of palynomorph with the high value number. So with the data from the table earlier, What does it mean with the Casuarina pollen being the most dominant pollen among the others in the studied rock samples? Casuarina dominant pollen indicates that the depositional environment of the studied sample has Kerangas vegetation and Kerapah type peat swamps. As you can see, the picture below is the Kerangas vegetation, and the right one is Kerapah type peat swamps or forests. That is what Casuarina pollen's dominant indicates. The second information that we can obtain from the data is there are no major compositional difference were perceived between the polynomorph assemblages in the coal and the non-coal samples. If you can see in the data earlier, in the non-coal section and the coal section of Casuarina doesn't have any significant changes. This means that the vegetation has no changes throughout the coal basin formation.
From the journals that we have covered, we can conclude that the abundance of Casuarina and the other three pollen types suggests Kerangas vegetation grew on the Kerapah type peats, locally bordered by rattans and pandanus swamps in a very wet climate. The coal forming peat also deposited in fresh mire with little or no marine influence from the low sulfur content and polymorph assemblage. However, both visual kerogens or measured analysis and palynology are useful tools to determine the formation of hydrocarbon potentials. They also help to determine the geological and biological aspect for the coal sample.